Okay, hello everyone, and welcome back to Chapter 2. Today we're going to be looking at rate of change and also some function modeling. So we're going to be doing two things today. So let's start with an average rate of change. What I've got here is a graph showing the distance that you travel in kilometers here. And here is the time in minutes, okay? So at 0 minutes, you haven't gone anywhere. At 5 minutes, for instance, you've gone 2 kilometers. At 10 minutes, you've traveled 4 kilometers, and so on, so on, so on. All right? So some questions. Suppose we want to find the average speed in kilometers per minute from t equal to 0 to t equal to 15. Okay, now we know speed is a change in distance over a change in time. So what we want to do at t equal to 0, we know we've traveled 0 distance. At t equal to 15, we know we have traveled 15 minutes. We know we have traveled 6 kilometers. Okay? So if you're going to find the change in distance, you want to subtract the two distances, the 0 and the 6 kilometers, which is the change in y values. So we want to do 6 minus 0, 6 minus 0, and then we want to do over the change in time, and the time was on the x-axis, so that's the change in x's, so 15 minus 0. I get 6 over 15. You can reduce that down to 2/5, okay? So the rate of change is 2/5 of a kilometer per minute, okay? So reduce it down. We've got 2. 3 into 6 is 2. 3 into 15 is 5. 2 kilometers per every 5 minutes, or basically 0.4 or 2/5 per minute, okay? And this ought to look remarkably like something you already know about. The change in y's over the change in x's. Speed is slope. Those of you going on to the calculus will be really working with that quite a bit, that the speed, the velocity of something, whether you're throwing an object up, throwing it down, the speed is the slope. Okay? What is happening from 15 to 35 minutes? From 15 to 35 minutes, what is happening? Your distance hasn't increased at all. It has stayed level at 6 kilometers. So you would know that you're stopped from time 15 to 35. Is B a local maximum? Is point B a local maximum? As long as the value at B is greater than or equal to values near to B, and yes, it is. It's equal here, but it's greater than or equal, so it is a local maximum. As a matter of fact, all of these points in here are not only local maximums, it's kind of strange, these are also local minimums because they are equal to or greater than for a maximum, or they're equal to or less than for a minimum. Point C is not a local max, it's a local min. Point B is not a local min, it's a local max. But everything in between is both, which is very strange that they can be both. Is D a local maximum? No, because there's nothing on this side, okay? We have points here that D is bigger than, but we need something on the other side to be able to call it a local maximum. All right, here we've got a graph. We want to do, once again, rate of change. This graph shown is x squared minus 2x minus 8, which you should have known because it's a squared term. You know it's a parabola. It's a positive squared term, so you know it opens up. Find the average rate of change from -2 to 1. From -2 to 1. What's the rate of change? Well, I see it going down. When we go from -2 to 1, I see it going down, so I know that it's going to be a negative rate of change. Here's what I suggest you do. Something similar that we did back here. We have x is -2 to 1. Okay? Find the two y values. At -2, I'm at 0. At 1, I am at -9. Okay, so let's just simply do delta y over delta x. So I've got -9 minus 0. By the way, it doesn't matter how you subtract, as long as you do it consistently. I'm doing this one minus this. Then I'd have to do 1 minus -2. Yes? Okay. Which gives me -9 over 3, or -3. Okay? The rate of change is -3. For every x that we go to the right, we go down 3. Okay? How about from -2 to 4? Well, just look at the picture. From -2 to 4. The rate of change, we have all this negative. This would be positive. Rate of change is 0. How about from -2 to 0? From -2 to 0, okay, do the same thing that I suggested a little bit ago. -2 is an x value. 0 is an x value. At -2, I'm at 0. At 0, I'm at -8. Delta y over delta x. 0 minus -8. -2 minus 0 is 8 over -2, or it is -4. Okay? Is the rate of change. Without doing a calculation, what do you think the average rate of change from 2 to 4 is? From 2 to 4. If from -2 to 0, from -2 to 0, we said it was -4. From 2 to 4, isn't it exactly the mirror image? So from 2 to 4, shouldn't it be a +4, right? What is the average rate of change? Wait, this is a different problem. From x equals -2 to 1 and y equals 2x minus 7. Do the same thing. Set up your two ordered pairs. X is -2, y is 1. Find the y values. When x is -2, is this not -11? When x is 1, is it not -5? All right, 2 minus 7, -5. Now, do your delta y's. I'll subtract this way. -11 minus -5, -2 minus 1. I get -6 over -3. Rate of change is 2, right? And why shouldn't you have known that without doing any work? What's the rate of change from -2 to 1? Is this not a linear equation, y equals 2x minus 7? When you go over 1, it goes up 2, over 1, up 2, right? Or up 2 over 1, however you want to do it. Isn't it consistently a slope of 2 everywhere? Okay? So you should have known you were going to get 2. Okay. That is finding a rate of change. Now let's talk about functional modeling. I want you to be able to write a function for a problem. Okay, so the length of a rectangle, geometry problem, draw a picture. Length is 5 more than twice the width. The one I don't know anything about at all is the width. W, the length, is 5 more than twice. 5 more than twice the width. Okay? Find the function that gives the area in terms of the width. You see that the way that's phrased? In terms of the width. When you see in terms of, it's telling you what the variable is. So I want you to write an area function where the variable is a W. Got it? Okay. So I know I'm going to write an area function, and I know the area of a rectangle is length times width. Now, from what I just said, I'm telling you that the width is your variable. So that means you cannot have an L in there. Okay? So we got to get the L out of it. Get the L out of there. All right, so it's the width times the length, and what was the length? 5 plus 2W. And there is your function. You've written the area. You pick any width whatsoever, okay? Punch it in there, and you'll get the area of the rectangle. How about number 2? Sides of a square are increasing at 5 inches per minute. So if you have a square, okay, if you let t be the amount of minutes, wouldn't you agree that the side of the square would be 5t and 5t because it's a square? In 1 minute, it'll be 5 inches. In 2 minutes, it'll be 10 inches. In 3 minutes, it'll be 15, and so on. Find a function that models the area of the square in terms of the minute. So I know the area is length times width, and I want the area in terms of t. Okay, wow. So I cannot have any L's or W's. I've got to have only a variable of t. Well, don't I know the sides, the length and the width would be 5t times 5t, or 25t squared. If you put in 1 minute here, it'll tell you the area is 25. 5 times 5. Yep, 25. You should be able to write a function for a problem. Number 3, sum of 2 numbers is 40. Find a function that models their product in terms of one of the numbers. So I know that 2 numbers multiply to give me 40. Okay? Find a function that models their product. So the product in terms of one of them. I don't care which one. I'll just pick x. Product is x times y. Yeah? But this tells me the variable is x. I cannot have a y in there. So I must use what I know here. I can figure out what y is. Divide both sides by x. Isn't y equal to 40 over x? So it should be find a function that models the, oh, for heaven's sakes. Sorry, I'm brain dead today. Let's start all over again. The sum of 2 numbers is 40. Okay, find the function that models their product. I had that part right. Product is x times y. Pardon me. Now, as I was saying, since your variable is x, you got to get the y out of there. You can go back up there and solve for y, subtract the x over, and you're going to have y is 40 minus x. Pick any x value you want, like 5, okay? Put 5 in here, 5 times 35 and 175. Sum of 2 numbers is 40, 5 and 35. The product is 175, yeah. Okay. Another one. Love these farmer problems. Farmer problem. A farmer has 800 feet of fencing, wishes to enclose a rectangular pen. Draw a picture. Okay? We have a length. We have a width. He wishes to enclose it with fencing and divide it into 4 smaller pens with fencing parallel to the width. 4 smaller pens. 1, 2, 3, 4. Yep. Okay. Find a function that models the total area in terms of the length or the width. Which one would you like? Length or width? I don't care. We're going to write an area function. I'll just pick L. You know the area of a rectangle is L times W. This tells me the variable is L. I must get rid of the W. I can go back to the picture knowing I have 800 feet of fencing to go around the outside and divide it into 4 pens. So would you agree? We have 1, 2, 3, 4, 5 W's and 2 L's have got to make 800, yes? Now, I want to get rid of the W to have my variable be an L, so solve for W. Subtract 2L and divide by 5. And there it is. I can replace the W with 800 minus 2L all over 5. Are you with me? Okay, that was a nice, interesting farmer problem. I love farmer problems. That was a hint about the next test. All right. Last problem. Find a function that models the surface area of an open box. Okay, so let's draw a picture. We have a box that is open. It means it does not have a lid on it, and you can see down inside from the top. Length is twice the width. Which one do you know the least about? Width. Length is twice that. Okay? And the height of the box is 5. Find a function that models surface area. So we want to do a surface area function. And it doesn't say. You could do it with L or W. I think because we know the least about W, I would do it with W. Okay? So how many sides? If we're going to do surface area, we don't have a top. So there should be 4 around the outside and 1 on the bottom. Okay? So we want the total surface area. So this space right here would be W times 5 is 5W. And isn't the 1 over there on that side also 5W? And then I have this space here, length times width is 10W, and there's 1 over here, 10W. So that's 20W. And then I have the bottom, W times 2W is 2W squared. You could consolidate that to 2W squared plus 30W. Okay? That is called functional modeling. Homework. I've got an extra problem. I want you to sketch the parabola, find increasing, decreasing intervals, domain and range, local max min points. To sketch that parabola, you might want to make a table with x's and y's, or if you find the zeros, set it equal to 0 and find where the parabola crosses the x-axis. Might be a little bit easier. A bit of a hint there. Good luck.